Hello everyone, this is Mr. H again and welcome back to my YouTube channel. In this video, I will be discussing with you simplifying radical expressions. Let's take a look at example number 1. So we were given 5 square root of 7 minus 2 square root of 7. Before we answer that question, let's recall some information about radical expression or radicals. Say for example, we have nth root of a. So this whole thing, we call it a radical expression, a radical. And each radical has major parts. So let's begin with the first one. This n right here could be any number. So n can be greater than or equal to 2. Okay, and it's an integer. So we call it the index. The a here, we call it the radicand. And the radical symbol or the radical sign. Example A. So we need to simplify the given expressions, and from here you can see that the mathematical operation is subtraction. All right, but in order for us to perform the given operation, we need to first, take a look at every single term given. But for this example, it's pretty straightforward because, as you can see, the two terms, we call them like terms. So when you say like terms, these terms belong to the same group. Because if you take a look at the given, so both of them have square root of 7. So it's like if we let x be equal to square root of 7, definitely you can have 5x minus 2x, right? And by recalling some important things in algebra, so 5x minus 2x is going to give you 3x. So you can put this together because they're like terms. And writing the final answer, you just simply replace the variable x that you initially represented square root of 7 with, replace it with square root of 7. And the final answer would be 3 square root of 7. So basically the rule here is that since each term, or both terms rather, have the same radical, right? What we just need to do is to just copy the radical, which is square root of 7, and we just perform the operation between the coefficient. So because the 5 here and the negative 2 here are coefficients of the radical. So we just take 5 minus 2 is 3. That's why the final answer is 3 square root of 7. All right, let's take a look at the second example. So we're given 2 square root of 54 minus 6 square root of 32 minus square root of 50 plus 6 square root of 6. All right, so before we answer this question, I would like to recall with you some information regarding one property. So we call it the product property of roots. If you're given nth root of a times b, and we can rewrite it as nth root of a times the nth root of b. So there's a restriction here. So n is greater than or equal to 2 and an integer. So this is what product property of roots is. Okay, so if you notice that nth root of a times b was actually split into two different factors, right? So we have the first factor, which is the nth root of a, and the second factor is nth root of b. So this property of roots will be applied here. We can simplify each term first. All right, so let's begin with the 2 square root of 54. So when we split or apply the product property of roots, we have to think of the largest perfect square factor of 54 of the radicand. So the radicand needs to be split into two factors, and one of the factors must be the largest perfect square factor. So from here, square root of 54 can be split into square root of 9 times square root of 6 rather. Then we move on to the second term, which is 6 square root of 32. So we're going to be applying the same property of roots, which is the product property. So we copy the coefficient 6 there. And square root of 32, 32 can be split into 16 times 2 is 32, okay? So we can have square root of 16 times square root of 2. Third term is minus square root of 50. And square root of 50 can be rewritten into square root of 25 times square root of 2. And for the last term, if you notice, it's already okay, right? It's simplified already. Just copy it. 2 times square root of 9 times square root of 6. So square root of 6, it's already simplified. We just leave it like that, the same as the last term. But square root of 9 can be simplified into, the square root of 9 is 3. So basically here is going to be 2 times 3 times square root of 6, right? Then minus, we copy 6, will be times, square root of 16 is 4. Square root of 2, that's already it, so we just leave it like that. Minus square root of 25 is 5 times square root of 2, we leave it like that, plus 6 times square root of 6, right? And then we keep going. So 2 times 3 here is 6, right? And then we copy 6 square root of 6. As you can see, the first term and the last term are like terms. They belong to the same group of square root of 6. So later we will be combining them at the end. Then the second term we have 6 times 4 is 24. And then square root of 2. And then the third term is 5 square root of 2. And the last term is 6 square root of 6. All right, so last step is combining like terms. So like what I mentioned earlier, the first and the last term. So we can put together this and the last one because they are like terms. So you got 6 square root of 6 plus 6 square root of 6. And for the next group, because both of them have the same radical, so square root of 2, square root of 2, so basically we can combine them. And we got negative 24 square root of 2 minus 5 square root of 2. And for the final answer, so like what I mentioned earlier, example A, if they have the same radical, so we just copy the radical. So for the first group, so we copy square root of 6. And then we just do the operation involving their coefficient. So we have 6 plus 6 is 12. There you go. And for the same group, so negative 24 and negative 5 combined, it will become negative 29. And we just simply copy square root of 2. And that is the answer. On to our third example. Square root of 3a times square root of 8a times square root of 4a. Okay, so if we're going to apply the product property of roots here, so the square root of 3a can actually be rewritten into square root of 3 times square root of a. Same goes for the second factor, which is square root of 8a. So it can be rewritten as square root of 8 times square root of a. And for the third factor, it's square root of 4 times square root of a. We can have square root of 3 times square root of 8 times square root of 4 times all the square root of a. We got 3 of them. We can have square root of, it's actually square root of 3 times 8 times 4. And then here you have square root of a times a times a. Square root of 3 times 8 times 4. 3 times 8 times 4 is 96. So for the first one, we have square root of 96 times a times a times a. So we're multiplying the same variable. So what we need to do is to add their exponent. So we have 1 plus 1 plus 1 is a to the power of 3. Next is, again, simplifying. So square root of 96. Okay, we can write it as 16 times 6. Because 16 is a perfect square. And I think that's the highest perfect square factor of 96 already. And we can leave the a cube. There we go. So square root of 16 is 4. So we take it out. And then we leave the 6 inside because 6 is, square root of 6 is already simplified. And then for a, square root of a cubed, let me recall one property of exponent here. If I give you this example, square root of 5. Square root of 5 is square root of 5. It's already simplified. So but if you are asked to rewrite this into exponential form, so basically we're looking at an index of 2 here, and the power of 5 as a radicand is actually 1. And if you are asked to rewrite it into exponential form, then we're going to be looking at 5. We just take 5. That will be the base. And we take the power of 5 inside the radical sign. That will be the numerator of the power. And the index 2 will be the denominator of the power. So the square root of 5 is equal to 5 to the power of 1/2. For this given, we're going to be rewriting this square root of a cubed into exponential form. And that is going to be, so we take a as the base, and the power of a inside will be the numerator of the power or the exponent. And we got 2 outside right here, which is invisible. And that's going, so 2 is the index. And that's going to be the denominator of the power. Okay, so the final answer here is 4 square root of 6 times a to the power of 3/2. And to our last example, simplify 10 square root of 30 divided by square root of 6. We're going to be applying the product property of roots, especially for the numerator, which is the square root of 30. Okay, so we copy the coefficient 10, and the square root of 30 can be rewritten into square root of 6 times square root of 5. Because square root of 6 times square root of 5 is square root of 30. So we just split them into two factors. Divided by square root of 6. And then from here, you can see that the square root of 6 in the numerator and in the denominator will be canceled out. And we will be left with 10 square root of 5 is the final answer. Alright, so if you learned something from this video, please hit the like button and share the video. And please remember to subscribe to my YouTube channel. Thank you very much for watching.